Hello everyone. Today's problem is count all the subsequence with some k. We have given that array 1 to 3 and the k, that is target sum 3. We have to find, or we have to count all the possible subsequence which sum will be equals to k. For examples, the given input array is 1 to 3 and the target sum will be 3. uh, if we count subsequence, first subsequence 1 2, that is sum of 1 2 is 3, it will be counted as valid subsequence. Now second one, subsequence 1 2 3, it is not valid because sum of the subsequence are 6, which is not equal to k, that is target sum. Now next subsequence is 3, which is equals to k. It will be counted, hence total possible subsequence will be 2, as it is the output of the given input array. Now for these questions, constraint will be given length from 1 to 20, means vector size, max size of the vector will be 20 and min size will be 1, and the element or integers in the given vector will be from 1 to 100, and the k varies from 1 to 2000. Now first we see the recursive tree, and then later will be see the code, and finally we can analyze the time complexity of the recursive code. Let's put the given input 1 to 3, index 0 1 to 3, its size is n is equals to 3. Here k is given is equals to 3, that is target sum. If sum of the elements of the subsequence equals to k, then we can increment the count, a count variable, to count plus count of variables to count plus 1. Okay, now take initial a sum variable and index variable idx. Initially these are initialized with 0 0. Now here simple, first there is two ways to choose. We can take this element 1 or not take. If we take, the sum will be incremented by 1 and index will be incremented by. If on another way, if we not take the element at the 0th index, then it will sum will be 0 and index also incremented by 1. Now further for these 1 comma 1, if we take the element at the index 1, then sum will be 3. Here sum 1 element at the index 1, 1 plus 2 equal to 3 and index will be incremented to 2. Similarly, if we not take the element at the index 1, that is 2, then sum remains 1 and index also incremented by 2. Here we can see, here we got the sum equals to k, that is it hit our base case, that is if sum is equals to k, the count plus per, it means it is the valid subsequence. Increment the count and from here function will be returned. Then next function will be called not take, then further call will goes take the element at the index 2, that is 3, the sum will be 4 and index get incremented to 3. Here again, now the index incremented and it hit the another base case, that is if a index greater than equal to n, then function will be returned. Then from here function will be returned and another function will call. Here sum is 1 but index is greater than equal to n, base case heated. From here function also get returned. Then now the left side of the functions all are returned to here. Now right side function not take function will be called. Similarly, element at the index 1 will be taken and elements will be index not take. If we take, sum will be 2 and index plus 2. Similarly, if we take or not take at element at the index, sum will be 5 and index incremented to 3. As the base case heated, it get returned back and it called not take function. If it not take, sum will remain to 2 and index will be incremented. As the index greater than equals to n, it will return back. From here it will return back. Now right side of the function will go here, element at the index 1 it will not taken, so sum will be remain 0 and index will be incremented to 2. Now at index 2 take the element at index 2, there is 3, it will be taken, the sum will 3 and index will be plus 1. As the base case heated, sum is equals to k count plus plus and return. From here it will be returned and the right side function will be called. Here right side function will be called. Here the sum is 0, f of sum is 0, and index get incremented as the it is not take side. Here base case is heated, that is index greater than equals to n, then a function will be returned. From here it will be returned. We return our final answer is equals to 2, which is saved on the count is equals to 2. Now let's see the code part. Here in the code, void function is taken, a variable index which is initialized to 0, variable sum which is also initialized to 0, given vector v, the target sum k, the count answer will be stored in the count which is passed by reference. It is important. If it not passed by reference, it will not updated each time. So it is very important to pass it by reference to get updated count every time when function will be called. Now as we see in the recursive tree, if index is greater than n, the return. Here first base case is if sum is greater than k, then function will be returned. Here one edge case is missing here. If idx greater than equals to n, function also get returned. Okay. Now if sum is equals to equal k, the count plus plus and function get returned. Now if it is valid index, the sum get plused by element which is at the index idx. After sum, the function will be called. After incrementing the index I plus 1 and some variable vector v, k and count will be passed. When it is completed and base case heated, when it return, then this will be called. It is important for backtracking. Sum will get minused by the element which is present at index idx. Then the not take function will be called after incrementing the index by 1. Basically it is take function and this is not take. This is the full code of the count the subsequence of here for each element. Now let's analyze the time complexity for each index or element we are calling two times. For take, for not take. So basically its time complexity will be big of 2 key power n, and the space complexity will be big of n, which is the size of the array, or you can say the depth of the recursive tree. This is the whole solutions of the count of all the subsequence with some k. Thank you.